In this video I'm looking at question 3 of the June 2011 Edexcel FP1 paper. The topic of the question is matrix algebra. The question's in 3 parts. In the first part we're given a matrix A and asked to find A squared, and then having done that, describe the geometrical transformation represented by A squared. In part B we're simply asked to find the geometrical transformation represented by a matrix B, and then in part C of the question we're given another matrix with an unknown value k and asked to find the value of k if the matrix C is singular. Well, in the first part of the question then, A squared is equal to the matrix 1 root 2 and root 2 negative 1 multiplied by itself, which is equal to taking the top line multiplied by the first column of the second matrix, is equal to 1 plus 2, and then the top line and the second column of the second matrix is root 2 minus root 2, so that one is 0. Going down to the second line of the first matrix and multiplying by the first column, we get root 2 minus root 2, which is 0 again, and then finally root 2 squared, which is 2, and negative 1 multiplied negative 1 plus 1. So that gives us a matrix which for A squared is 3, 0, 0, 3. For the second part of this section, we're asked to describe fully the geometrical transformation represented by this. So this is an enlargement, scale factor 3, center the origin, so 0, 0. The marking for this part of the question was a method mark and an A mark for calculating A squared, and then 2 B marks, one for saying enlargement and a second one for getting both of these parts into the description. So the scale factor 3 and the center, the origin. So a total there of 4 marks for section A of the question. In part B of the question we're asked to describe fully the geometrical transformation represented by this new matrix B. Remember that any matrix transformation, we can think of the columns as making up I dashed and j dashed. These are where the unit vectors I and j, which lie along the x and the y axis respectively, it's where these end up after the transformation. So I dash is at 0, negative 1, which is down in this direction, and j dashed is at negative 1, 0, so that's along the negative x-axis. So we then have to think about, well, what transformation will produce that, and the transformation is going to be a reflection in this line. So it's a reflection in the line y equals negative x. The marks for that were again B marks, so no method required, but you simply needed to state that it was a reflection for B1 and get the line y equals negative x for the second B mark. So 2 marks for that part of the question. In the final part of the question then, a new matrix C, and we're asked to find the constant which is unknown in C, k, for which C is singular. So we need to know the definition of a singular matrix, and that is the fact that the determinant of C must be equal to 0. So the determinant, remember, we calculate from multiplying the leading diagonal. So that's 9 multiplied by k plus 1, and subtracting from that the product of the other diagonal, 12 times k. So that must be equal to 0, and that's a fairly straightforward equation to give us minus 3k plus 9 is equal to 0, and therefore k is equal to 3. 3 marks here, a B mark for knowing that the determinant is equal to 0 for a singular matrix, and then a method mark and answer or accuracy mark for calculating k is equal to 3. Well, that completes that question. Other questions for this module, and indeed for other modules in the course, can be found at www.furthermaths.org.uk.